વેલ્યુ એને બી સબટ્રેક્ટ કરાય. આમાં ફરક કોઈ નહીં પડે આન્સરમાં. કેમ? કારણ કે જો see first observation, delta T1, that is T1 minus T, so 2.63 minus 2.62, so that is 0.01. Then delta T2, T2 minus T, that is 2.56 minus 2.62, that is minus 0.06. હવે જો અત્યારે આપણે મેઝર્ડ વેલ્યુમાંથી મીન વેલ્યુ સબટ્રેક્ટ કરી, એના બદલે જો મીન વેલ્યુમાંથી મેઝર્ડ વેલ્યુ સબટ્રેક્ટ કરીએ તો અહીંયા જે આન્સરમાં જે પોઝિટિવ વેલ્યુ આવી છે એ નેગેટિવ થઈ જશે અને જે નેગેટિવ વેલ્યુઝ આવી છે એ પોઝિટિવ થઈ જશે. વેલ્યુ તો એની જ રહેશે. Clear to all of you? Yes, so in this way, now we have to calculate the absolute errors in individual observations. So now here, in all the 5 observations, the individual errors are calculated. Some are positive, some are negative. But when we calculate delta T mean, means average absolute error at that time, we have to take these absolute errors in mode. Means we have to consider only positive values. It implies that delta T mean, that is equal to mode delta T1 plus mode delta T2 plus mode delta T3 plus mode delta T4 plus mode delta T5. See, delta T1, that is 0.01 substituted here. Then delta T2, that is minus 0.06, but here we have to take mode. So simply we have to write plus 0.06. Then after minus 0.2, but here we have to take plus 0.2. Similarly, plus 0.09 plus 0.18 divided by 5. When you solve this one, you will get answer 0.11 second. Now relative error. So relative error in periodic time, that is delta T mean upon T. Delta T mean is calculated here 0.11 and T is calculated here 2.62. So take ratio 0.11 upon 2.62. You will get answer 0.04. Now percentage error. So percentage error will be obtained by multiplying relative error with 100. So delta T, the relative error, into 100. So 0.02 into 100, that is 4%. Now the final result you can represent like this. Periodic time, that is equal to 2.62 plus or minus absolute error, that is 0.11 second. Or you can write 2.62 plus or minus 4%. Suppose in 2.62 we add 0.11 and we subtract 0.11. Then our answer will be 2.51 and 2.73. It implies that we can say the value of T lies between these two. So T is greater than or equal to 2.51 second and less than or equal to 2.73 second. એટલે આનો મીનિંગ એ થાય કે T ની વેલ્યુ 2.62 સેકન્ડ છે પણ એમાં 0.11 સેકન્ડની એરર હોવાના ચાન્સીસ છે. અથવા તો એવું કહેવાય કે 2.62 second, that is the periodic time for the oscillations of simple pendulum. But there is the error about 4% in the measurement. એટલે 4% ની એરરના આ મેઝરમેન્ટની અંદર ચાન્સીસ છે. આવી રીતે પછી ફાઇનલ ઓબ્ઝર્વેશનને તમારે રિપ્રેઝન્ટ કરવું પડે. એટલે આપણને ખબર પડે કે ભાઈ આ મેઝરમેન્ટ એ કેટલી એક્યુરસી વાળું છે. ચાલો, ક્લિયર ટુ ઓલ ઓફ યુ બેટા?
Yes, sir.
Yes, sir.
Now, example 2.6. Very simple. Two clocks are being tested against a standard clock located in National Laboratory at 12 noon by the standard clock. The readings of the two clocks are for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. The readings are given to you for clock 1 and clock 2. Now, if you are doing an experiment that requires precision time interval measurements, which of the two clocks will you prefer? Okay. Now see, here, see the observations. So we can observe this thing. Clock 1 is giving you the observations which are very close to 12 o'clock. But the observations by clock 2 are differing more compared to 12 o'clock. But see here, suppose we think about the variation in measurement, then see the observations of clock 1, observation on Wednesday 11:59 and 08. So 11 hour 59 second, sorry 59 minute and 08 second. That is the smallest observation. And on Saturday 12 hour 1 minute 30 second, that is the largest one. Now if we take the difference between this smallest one and largest one, then that will come to 162 second. Similarly, for the observations by clock 2, the minimum and maximum are on Friday and Saturday. See, on Friday 10 hour 14 minute 53 second, that is the minimum one, and 10 hour 15 minute and 24 second, that is the maximum one. But the difference between minimum and maximum, that is 31 second only. So variation in the measurements by clock 1, that is large one. But variation in measurements by clock 2, that is a small one. And here, say, if you are doing an experiment that requires precision time interval measurement, so more precise, that is clock 2. More precise, that is clock 2. And you want the precise one, means you have to use clock number 2. Clear to all of you? Or any doubt in this one?
No, sir.
Combination of errors. So why we have to think about now combination of errors? Because see, in practice, what happens? Suppose we have a rectangle. Okay. Now, for that particular rectangle, we measure the length and breadth. And then after, suppose we want to calculate the perimeter of that particular rectangle. Then we take the summations for length and breadth. Okay. Now, suppose in the measurement of length, there is some error. In the measurement of breadth, there is some error. But now we take the summation of length and breadth, then what will be the error in the final result? That we have to think. Then we take the multiplication, division of different physical quantities. So if the measured values of the quantities are with errors, then when we take summation, subtraction, multiplication or division of the physical quantities, at that time, what will be the resultant error in the final result? That is called combination of errors. Clear? So now here we have to discuss the combination of errors. Okay? Now see, first we have to discuss error of sum or difference.